In today's lecture, we're going to be talking about solubility a little bit more. So we're going to look at factors that impact ionic compound solubility. So remember, an ionic compound, we've got some anion, some cation, and it's going to be in equilibrium with its soluble form. If we have a less than soluble salt. So if we have a less than soluble salt, we have solubility. It's an equilibrium process. So we're going to look at how we can tip that equilibrium in one direction or another. One thing we can do is we can add in a common ion. Okay, so something like XA. So once we add this ion in, it adds in, and it's going to shift our equilibrium back towards the solid. So adding in a common ion will decrease ionic salt solubility. Okay? And we can do calculations to prove that, and we will. We can also look at it pH. So we have a couple ways that pH will affect our solubility. One, if we have a ionic compound that contains a basic anion, then as you increase pH, you decrease solubility. So, for instance, calcium fluoride. When we dissolve calcium fluoride, we produce a basic salt, right? That it comes from HF. HF is a weak acid, so it produces a weak conjugate base, so this is a basic anion. When we increase the pH of the solution that it's in, we're going to decrease our solubility. So if we start out at 1, we look at our calcium fluoride molar solubility. It is going to decrease as we increase our pH. To nearly nothing. Another thing that will happen, so we have some metal oxides and metal hydroxides. As we change the pH, we're actually going to increase our solubility. So metal oxides and metal hydroxides will increase solubility as you decrease or increase the pH. As in, be more soluble and acidic or basic solutions versus pure water. Okay, so we can think about aluminum hydroxide. Okay, as we add in OH minus, we will shift our equilibrium towards a soluble form. This is a complex ion. So, as we add in, we're going to shift in that direction. Okay? We do the same thing. Take our aluminum hydroxide, and when it reacts with H+, we produce aluminum 3+ ions and water. So, as we add in our H+ ions by decreasing our pH, we're going to shift towards our soluble form of aluminum. Okay, so pH will affect ion solubility in different ways. So if we have a ionic compound that contains a basic anion, increasing pH will decrease solubility. If we have metal oxides or metal hydroxides, increasing or decreasing our pH versus pure water will a lot of times cause a increase in solubility. We also have complex ion formation. Which we already saw one example of that right here. But complex ion formation, this is taking a metal cation plus a Lewis base and producing a complex metal ion. And this is soluble. This is very favored, and as such it increases solubility. Increases solubility of an ionic salt or ionic compound. So let's look at how this works. Let's take aluminum chloride. Okay, so aluminum chloride has a specific KSP associated with it. However, that aluminum, or sorry, not aluminum, it's supposed to be silver chloride. Excuse me. So silver chloride will break down into silver ions and chlorine ions, and this has a fairly low KSP. We can see this with silver chloride, AgCl. Silver chloride breaks down into silver ions and chlorine ions, and this process has a small KSP of 1.8 times 10 to the negative 10. So it's not a very favorable process. However, if we take and add in a Lewis base, such as ammonia, it will form a complex ion with silver. Okay. So I'm just going to move that over there. And that has what we call a KF, so equilibrium constant of formation of 1.7 times 10 to the 7, very large number. So very favorable. So our complex ion forms very easily, this one right here. And whenever we form this complex ion, it uses up this, right? So we have here and here. So our formation of a complex ion removes silver, which causes a shift in our equilibrium towards solubility. So if we're thinking about our molar solubility of AgCl versus NH3 concentration, as we increase our NH3 concentration, we're going to increase our molar solubility of our silver chloride. That's because as we add more in, we're shifting our equilibrium towards soluble, forming this complex ion. Okay. So those are the ways that we can look at solubility and how we can impact solubility of an ionic compound. So either through common ion effect, pH, or complex ion formation. We can also take advantage of solubility and the formation of complex ions to selectively precipitate out different ions. So if we have two ions in solution, you can take advantage of the KSB of salts that they form to cause one ion to precipitate over another one. We could also use complex ion formation to solubilize a non-soluble salt to separate two insoluble salts. So for instance, we had two hydroxides. Hydroxides are generally insoluble, but if we have something like iron hydroxide and silver hydroxide, they're both insoluble. In water. However, we can add in ammonia, and ammonia will make a complex ion with silver but not iron. So we can remove this, and that will be in solution. So it's a couple ways we can separate out specific ions or separate out different salts. That is everything for this lecture. We'll see you in class later. Have a great day.